Domain and range of a relation. This will be a little different. I'm doing this on my Mac, so let's see what happens. A relation can be represented as a set of ordered pairs, or a table of values, or words, etc., etc. The domain of a relation is the set of all the first elements of the ordered pairs, and range is the set of all of the second elements. This tablet is now set relative to the screen, not otherwise. Elements of the ordered pairs. Sorry. Recall the relation is a function if each element of the domain is paired with exactly one element of the range. Domain and range for discrete data. State the domain and range for each of the following relations and whether or not it is a function. Okay, domain. Domain is a set of numbers. -3, -1, 0, 2, 5. So we look at the first elements. -1, 0, 2, 5. This is a function since no element of the domain was repeated. Although if it were, we would only list it once anyways. And the range, -2, 4, which appears twice, but we're only ever going to write it once, 5, and 8. So you can see from domain and range, we can't rebuild this relation. We have no idea how these go together. I mean, there are 1, 2, 3, 4, 5 elements of the domain, and only 4 elements in the range, so we know the range element is repeated, but we have no idea which. Moving on. Domain, John. Although really, I guess if I'm going alphabetical, Jeff, John, and Kelly. And the range, 7, 8.5, 10. And this is a function. If the student had 2 different shoe sizes, then it would not be a function, but this is a function. I guess we should write that in, right? Function. Function. Tim has a height of, this better be a function because one person shouldn't have more than one height. Alphabetical. We don't have to, we can list them in any order, but Cal, Jim, Sharon, Tim. And arrange 165, 180, 188. And we don't put any element, or sorry, units on the range. And this is a function. On the PC, the tablet is relative, and to the screen and on the Mac, it's absolute. So this is not a function. Scroll down here. Not a function. And let's just the elements in the domain. So easiest way to do that is just go from left to right. So -3, -2, nope, 0, 1, not 2, not 3, but 4. And the range, and even though the domain element 1 will appear twice, you'll have 1, 2, 1, 3, we only ever list any element of the domain or range once. For the range, let's start at the bottom and work our way up. So we've got -3, -2, 1, 2, 3, 5. -3, -2, 1, 2, 3, 5. And here we have a nice little graph. Ages and and masses of people. So 4, 6. Now this, is a function because every element of the domain only appears once. And so let's list those. It'll take me to get used to. So 4, 5, 8, 12, 14, and 16. And for the range, start at the bottom, work your way up. Oh, which is mass, yeah, so it's 20, 25, 45, 65, 80, and 85. Kind of shaky in that, and this is a function. Though it could well not be, since it would be very easy to have two people with the same age. But it is a function. So let's move on. Domain and range for non-discrete data. So you notice on the last page the data was discrete. It was ordered pairs, it was points on a graph, it was lists of names, it was individuals, and again, points on a graph. But what if the data is not discrete? What if it's continuous? When listing individual data values, or when listing individual data values are not sufficient in describing the relation, we need to use symbols like less than, greater than, less than or equal to, greater than or equal to, belongs to, and equals in order to do so. Example 1. Set builder notation and acceptable. So the full meal deal. The domain is the set of all x such that, vertical line means such that, x, well what about x? X is greater than, this is the smallest value for x, is -3. Otherwise, and the arrows indicate it goes on forever. So x is greater than or equal to -3, and x belongs to the reals. So one more time, the set of what? The set of all x. What about x? Such that x is greater than or equal to -3, and x belongs to the reals. Range, set of all y. What about y? Such that. Now, since these arrows will go down forever and up forever, we will cover all y values. So this is the set of all y such that y belongs to the reals. Acceptable notation. What's the least we're going to take from you? So, domain x is greater than or equal to -3. Range y belongs to the reals. So what we'll say is, when I see something written like this, I will assume that it means that x belongs to the reals. If the value only belongs to the reals, then we have to state that outright. So y belongs to the reals. Let's take a look at this. Set builder notation. This is the set domain. The set of what? X such that. What about x? Well, in this case, x is only equal to -4. There's no other possible value for x. The range such that y, well, remember the open circle means it does not include, so y has to be less than 5. Strictly less than, not less than or equal to, and we will also state that y belongs to the reals, meaning that it's every real number less than 5. Okay, means we don't include 5, but less than 5. Acceptably, what could we write? Domain x equals -4. Range y is strictly less than 5. Again, if we state something like this, the assumption is that y belongs to the reals. Example 3, set builder notation, domain, the set of all x such that. Well, what do we know about our x's? They go from 10 to 45, right? We can get any x value between 10 and 45. So here's how we do it. We start with the lowest value, 10. Is less than or equal to x is less than or equal to 45. We will only ever list a range of values this way. The smallest value is less than or equal to, or strictly less than if this had open circles, x, which itself is less than or equal to 45, and x belongs to the reals, meaning that it can be all values between 10 and 45, including 10 and including 45. Okay, what about y values? Well, they go from 30 all the way up to 60. So we are going to say that our y values are in the range between 30 and 60. And acceptably, domain 10 less than or equal to x less than or equal to 45, and the range 30 less than or equal to y less than or equal to 60. From now on, you do not need to use the set builder notation unless specifically asked to do so. In other words, we'll take sort of the abbreviated version. State the domain and range. Remember, we can't really determine these things, so we're stating the domain and range for each of the following relations and whether or not it is a function. Use the appropriate variables. So in this case, the variables are x and y. Our x values go from 0 to 6. So 0 less than or equal to x less than or equal to 6 is the domain, and the range from -3 positive 1, and you're going to be doing a lot of this. So get this notation down, think about it, have it so it makes sense to you. Vertical line test, no, so not a function. And remember, the vertical line test can only be used to rule it out, not as a definition. In this case, our variables are t and h, so we have time and height. The time goes from 0 to 4. 0 less than or equal to t, which is less than or equal to 4, and it's assumed that it's real numbers. And the range goes up to 80, from 0 to 80. 0 less than or equal to h, less than or equal to 80. And this is a function, since no time value could have more than one height associated with it. This is one single object. It can't be in two places at the same time. Whoops. Okay, we've got x's and y's. Notice the arrows on both ends. So the domain x belongs to the reals. Since this will keep going forever, it's going to cover off all the negative x values. This will cover all the positive x values. And the same thing's going to happen with y, up forever, down forever. So the range is y belongs to the reals. Is it a function? It would pass the vertical line test. There's nowhere we could draw a vertical line. So it is quite functional. If variables aren't given and it's a grid, then we will assume x and y. The domain, well, you notice we have any value going this way, but the highest x value is 2, so the domain is x is less than or equal to 2. It can be 2 or any number smaller, since the arrow goes on forever that way. And x belongs to the reals, which we don't say. And the range, well, this goes down forever, this goes up forever, so y belongs to the reals, and not a function. since we have this vertical line. This is a vertical line which is there, so of course it would fail the vertical line test. Speed and time, and this is given in us unusual notation or unusual graph, because usually we put time here and speed here, but it says that if we're going really slow, we're going to take a lot of time, and if we're going very fast, we're going to take a little bit of time. Domain. Well, our speed has to be greater than 0. So that's S is greater than 0. You notice our speed can't be 0. I guess if our speed were 0, we'd never get anywhere. So, and our range is, well, your time can't be 0. We can't get there instantaneously, wherever it is we're going. So time. So speed is strictly greater than 0, not greater than or equal to. We can't be equal to 0, nor can the time be equal to 0. And although this climbs, what it looks straight up, it is in fact a function. There will never be, for a given speed, there will never be two different times. I got to get used to the tablet orientation. Exercises. Okay, so the lesson part is done. I will go through the exercises. I'll just kind of whiz through these. So if you want to watch, then you can see, or if you're looking for a key. So domain, it's a set 0, 2, 5, 8, and I'm just putting it in order. That way if we're looking, we all get the same numbers. And the range, it takes a little more looking around. -3, -1, 5, 7. -3, -1. Now these have to be written in set notation. Each element of the domain occurs only once. These have to be written in set notation because we can't just say x is or whatever. Domain -3 and 40, we will not repeat domain elements, even if they're repeated. And here, 4, 5, 6. And we can say, hey, wait, these two values. Nice no. No, not a function. Domain, list the names. I don't know if I'd bother with, but I'm going to. J, so Jill, Lucy, Steve, Susan. Range. Now wait, if I want to do alphabetical order, female, male. Function. Is it a function? Yeah, because hopefully 1. Whoops. No individual is repeated. Domain. X equals -4. If we don't list a variable, the domain will always be X. And range is the set. So you could write it like that, or you could just say it's the set consisting of -4. And for the range, I don't want to say y equals. I actually do want to do this as a set because there are 3 values. Is it a function? Well, -4 is associated with 3 elements, so no. Domain -3 or x equals -3, and pay attention to the variable. And the range, we'll list these: -2, -1, 0, 1, 2, 3. Function? No. There is only one element of the domain. Every element of the range is associated with it. Number of people. Domain. 0, 10, 20, 30, or 40 people. And the range, I'm never going to get used to this. This will be 50. So 50, 100, 150. 50, 100, 150, 200, 250. Is that a function? Yes, it is. There are no two dots, one on top of the other. All right, is there more? There is more. Domain. No, wait. Said we could go with short form. I was going to write the set of all x. So just x belongs to the reals. The range is y belongs to the reals. And yes, it is. Domain. X is greater than or equal to -4. The solid dot means that it's included. Oh, wait, you're not looking. Because that's not an arrow on the end. I like that eraser. It's nice and big. So -4 is less than or equal to x, which is less than or equal to 5. So we have the x values between -4 and +5. Remember, low value, less than or equal to variable, less than or equal to high value. We never flip it around and write it the other way. Low value, -1, is less than or equal to variable y, which goes up to 2. And it is a function, passes the vertical line test. We could take a vertical line and run it through this. It would never intersect the curve at more than one point. Domain. So what's 1, 2, 3, 4? 300 divided by 4 is 75. So 6, 75, 750, 825 is what that is going to be. So our domain is distances from 0, and it's d is less than or equal to d is less than or equal to 825. And our range, which is liters, so let's just see, do we have a capital L? Yes, we do. So what's our scale here? It looks like tens. 10, 20, 30, 40, 50, 100, 110, 120, 130. So smallest value first, 0, less than or equal to L, less than or equal to 130. Function? You betcha. Yes, it is, since any given distance will only have one number of liters associated with it. Okay, how about here? We have time going from 0 to, what's our scale? 1/2, 1. Always look at your scale. We always assume they're ones. I almost always assume, so I would think that was 5, but really it's 4.5. So domain 0, less than or equal to, the variable is t, less than or equal to 4.5. And the range, 0 is the small value, 80, 90, 100, 110, 120. So I was just thinking it's tens, 90, 100, 110. So 0, less than or equal to h, which is less than or equal to 80, 90, 100, 110. 110. That's a 1. Is that a function? Yes, it is. Right? Any given time only has exactly one height associated with it. Domain looks like every x value is covered, so x belongs to the reals. Ranges go up to 0, so y is less than or equal to 0. Right? Any value less than 0. Is this a function? Vertical line test says yes. Domain, this starts at -1, so x is greater than or equal to -1. If this were an open circle, then it would be greater than -1. Range starts at 2 and goes up, so y is greater than or equal to 2. And again, if that were an open circle, this would be strictly greater than, and this is a function. And up come a couple of reminders. Domain, so this starts at 3 and gets lower, so x is less than or equal to 3. Range, these arrows are going up and down forever, so y belongs to the reals, and of course it fails the vertical line test, so it's not a function. Domain, x belongs to the reals. Range, y is equal to 2, and yes, it is a function. So horizontal line will be a function, and in this case all y values are 2, but x can be any real number. Domain, well, we got time in minutes. It's going to, what's my scale? Looks like 2s, 2, 4, 6, 8, yeah, so that's 26. So 0, less than or equal to t less than or equal to 26. And the range, minimum value of 0, maximum 40, 45, 50, 55, 60, 65, 70. So 0 less than or equal to, variable is d, which is less than or equal to 70, and that is a function. Domain goes from -2 to 4. -2 less than or equal to x less than or equal to 4. The range, -3 to 3. -3 less than or equal to y less than or equal to 3. And no, it is not a function. It would fail the vertical line test. This goes on forever. X values that way. This goes up, so it will cover all x values. So x belongs to the reals. This is not going to, this is what we call an asymptote line. So the range is y is greater than 0. The y value will never get to 0. This asymptote line is a line a curve approaches but never touches. And yes, this is a function. If you graph this, it's going to look something like this, only not as bad as that. And it's got that point there. So the domain of this is that x belongs to the reals. The range is y is greater than or equal to -5. And yes, this is a function. And we are done